Hello, I'd like to talk to you about how to do variance and standard deviation. The formula for sample variance is, and let me get my pen here, and actually let's go over here. I think I'll write in red. So let's say you have summation, then we have xi minus the mean, all of that squared, divided by n minus 1. And again, this is for the sample variance. So now, just to make it a little bit easier to see, I'm going to type it in. Actually, let's say we have 4 people, and one person in our class is 18, another is 19, another is 21, and another is 25. So we've taken a sample. We have quite a few people in our classroom, and we just take a very, very small sample of 4 people. And so we want to take this top part. So we take x would be the 18, 19, 21, and 25. So we take 18, which is 1x. So there's one of the x's right there. Minus, and what's our average? If I add all 4 up and divide, I get 20.75. Then I want to add 19, or minus, don't want to add it, but minus 20.75. Then the 21 minus 20.75 plus the 25 minus 20.75. Also, I want to square those terms, because notice we just took how far away each term is from the mean. So if you take the number, subtract the mean from it, just how distant or how much does it deviate from the mean. We want to square it. Forgot to put my square in there. Actually, I didn't forget. I just wanted to show you the first part. But there's our squared terms. I'm going to put a caret for the square. And so everybody hopefully is clear that this little, call it a caret, means raise it to the power. Now, so we've got the sum of each of the terms. Now, please notice, you square each of the terms separately. So now, let me get our pen up here. Now we want to divide by n minus 1. I've got 1, 2, 3, 4. N is 4 minus 1, which obviously is hopefully 3. So if I take 18 minus 21, 20.75. In fact, I'm going to just write it in. So 18 minus 20.75 is minus 2.75, and then we're going to square that. Then the 19 minus, we're going to square all that. And then the 19.20.75 is negative 1.7. And actually, I want to add that, don't I? 1.75. And that's squared plus, so there's the plus, 21 minus 20.75. Once I get to how far away you are from the mean, you're pretty close to the mean. You're just 0.25, and we'll square that, and then plus, if it stays there. 25 is a bit above the mean. In this case, it's a little over 4 years away from the mean. 4.25, we're going to square that too. So notice 18 is about almost 3 years below the mean, not quite. 19 is almost almost 2 years below the mean. 20, almost 21 is our mean. And then if you look at 21, it's a fourth of a year higher than our mean. And then 25 is a little over 4 years above our mean. Now we divide all those by 3. 4 minus 1 hopefully is 3. Now we're going to square the terms. I get negative 2.75 is 7.5625 plus negative 1.75 is 3.0625 plus 0.25 squared. Hopefully it's clear there's a little 0.25. That is 0.0625 plus 4.25 squared is 18.0625. And I'll put my, let's make that look a little better for our division here. I'll get rid of those two. Okay, now let's see if I can write a better. So, and then that divided by 3. And all that is equal to, what is all that equal to? I calculate, get my pen here, I calculate that all equals to 9.5833. So if I add them all up, and actually let me give you the numerator and the denominator, adding them all up, I got that it was 28.75 divided by 3, and that is equal to 9.5833, and that's our variance, sample variance. Now if I'm take the square root of that, if I'm trying to find my standard deviation, I can type it in here. You take the square root of, better square root sign, 9.5833, and I'll take it all the way over, and that's going to be 7.1875. So there's our standard deviation, and here is our variance. So hopefully it's pretty easy to calculate. Now some teachers or some people might say, well, what's about if you only have a class of 4? So instead of there being the sample variance and standard deviation, what about if you're trying to calculate the population's variance and standard deviation? Well, if you're trying to do the population, you just don't, instead of dividing by 4 minus 1, you divide by just the total number of observations, or actually the total population. So in this case, I'm going to put this in green, just in case you have a question about the population. So if you have to do the population, and let's, okay, so in this case, if you're doing population, I'm going to write a little population, which would be the 28.75, because the numerator is the same. So we're treating it as if there's only 4 people in the classroom. We have one person who's 18, one person 19, one person 21, one person 25. All of this work is the same for the population. So instead of dividing 28.75 divided by 3, we just take 28.75 divided by 4. It's the only difference. And that's what you do if you are looking at everybody possible. So if it's for the United States, you look at all, and you're looking at the variance and standard deviation for the population, you look at over 300 million people. In our case, fortunately, we assume this is a classroom of 4 instead of just taking a sample of a classroom larger than 4, like 5 or more. And so in this case, 28.75 divided by 4 is going to be 3.095696. And then to take the standard deviation, you just take the square root again. But the only difference if you're doing population is just don't subtract 1. Now, most cases you're going to be doing the sample like we did in red. So hopefully that if somebody asks you about population, you say, oh, that's simple. I just divide by the total number rather than total number minus 1. Or the sample, how many I took in my sample minus 1. So in this case, I have 4. So I just divide by 4. If this is a sample of a larger group, I take 4 minus 1. Pretty simple. Hope you have a wonderful day. Talk to you later.